This video is about to test whether direction of airflow matters or how much I need to clean up my desk. So what I'm trying to do with this setup is make sure that I have pretty much the same connection to the fan, whether I'm blowing air into the filter or blowing air away from the filter. Either way, the air is going to go through the filter, but the question is whether the high pressure end of the fan is going towards the filter, the low pressure end of the fan. So this one is the pump is moving air out from the filter using the high pressure of the atmosphere to push air through the filter. And right now I'm just seeing that I have a reasonable seal here so that my test is fair both ways. So this is the conventional setup. I set the fan that I'm using to 2 watts. It's a 12 volt 0.35 amp fan, and currently it's running at 9.77 volts. I guess about 0.2, something close to 0.2 amps. I'm going off of the watts to be consistent. I'm going to keep the voltage the same for all trials, even if the wattage fluctuates slightly. Now we'll see how long it takes to fill up 50 milliliters. Start timer. Oops, I made that same mistake again. I think by now I would know that Google is going to respond to stopwatch and timer as different things. So I have to ask it to start the stopwatch. I guess internally in my head I'm timing something, so to me that's a timer. Start stopwatch. And we'll see how this feels. That's full. I had some trouble stopping it, but we'll call it 26 seconds. Oops. Alright. Stay. And of course, I don't play music in my videos. I figure if you want to listen to music, you can play your own music. I'd recommend Boots Riley The Coup. Kind of like if I was to play music right now, that's what I'd be playing. I really like the movie Sorry to Bother You. It's actually very appropriate for these times. Let's see, so we had, we'll call 26 seconds. Since it's kind of difficult to change this setup, I'm actually going to do, three trials all in the out direction before I switch to the in direction. Let's see, I'm going to try to adjust this inlet so that it's going to attach a little bit more quickly by making it wider if I can. fact, I don't even think I need. Have to be careful not to rip the bag, because then this won't work at all. But I think for this particular set of trials, I should be able to just connect the hose. Yeah, I get a nice connection. Not perfectly airtight, but pretty close. It'll be the same connection either way, and that's a much quicker connection to make, so I think I get more accurate time. So I'll leave it. Previously it was designed to connect to the hose without this cap. So with that end cap, I can just plug it in much more quickly. And we'll get 2 more times. And let's see, here we go. Start stopwatch. Okay, that went a lot more smoothly. Waiting for the bag to fill. Hopefully you can kind of see that on the camera. I'm going to wait until the bag is tense and then stop it. Okay, 27 seconds. The seal kind of came around, made it tough to, I guess the seal slipped on around. If the seal kind of randomly comes down, that could actually throw off the trials a little bit, but I don't think it will be a significant amount, because the amount of air that will leak through that seal is pretty small. So looks like we're within a few seconds accuracy. So that's about 1 part in 30. It's good to kind of look at inaccuracy relative to, in proportion to the measurement. So like if I'm off by 1, let's start the timer again. Uh-oh. Looks like we'll have to reset this up. That would really mess up the timing if this wasn't connected. This kind of, don't know if you can kind of see in the video that this popped off. So let's say I'm off by a mile. If I'm measuring something that's less than a mile, that's going to be a real problem. But if I'm measuring 1,000,000 miles, well, it depends on the application, but the degree of imprecision of 1 mile over 1,000,000 miles is much less significant than, say, 1 mile out of 10 miles. So that's what I mean when I say the proportion is important. So in this case, I'm measuring how many seconds to fill up roughly a 50-liter bag. And if it's taking me about 30 seconds, and I consistency, my measurement is about to the nearest second. Then that's 1 part in 30. I'm accurate to at least the nearest 3 seconds. That's 1 in 10. That's not, again, like the degree of accuracy, it's in comparison to what you're looking for. That's still enough. 1 part in 10 is enough to see if there's a big change or not. Oh, this is being kind of difficult. Huh. Maybe it might work better if I attach. I'm going to try first attaching this lid to the fan. And then plugging the lid onto the hose. Let's see if maybe that goes a little bit better. Okay, just need this to last through one more test. And then we'll go on to the next setup. This is a very definition of flimsy, which I went over in a previous video. This structure is what I mean by flimsy. All right, let's see. Start stopwatch. Oh no, oh, that was the right command, but I thought I was making a mistake of telling it. Do the other thing and start the timer. All right. Start stopwatch. Okay, so we're filling up the bag. And filled at 30 seconds. So it's looking like my accuracy is probably 1 part in 10. And now I'll change the setup. I think the other way will actually be an easier setup. So there's a main advantage to having it set up this way where the fan is taking air from the filter, which is, the filter is effectively going to protect the fan. A downside is that if there are any leaks in the fan, then that air that's leaking into the fan isn't going to be filtered. If I have the filter blowing air, if I have the pump blowing air towards the filter, Then there's the advantage of absolutely all the air, as long as I have a good seal on the other side, all the air is going to be filtered, whether or not there's any leakage from the fan. Oops. Need to be careful about touching the moving part of the fan. Technically, I probably should have turned it off for that. There are fans that have very sharp blades. That one, even this fan could probably hurt you, but there are some fans where if I made the mistake that I just made, could potentially lose a hand. So it's a good practice to turn off equipment when you're working with it. So what I'm doing is I'm just switching the hole that was where the fan was. That's still going to be where air is leaving, but in this case the fan's going to be in a different spot. Let's see, how am I going to set this up? Okay, so the fan is going to be down there. I wonder if this will, that will actually hold the motor. So I'm going to have actually pretty similar setup to what I had before. I'm going to first put the fan in here, use a little bit of tack, so you can't say I'm tactless because I have plenty of tack regardless of my fashion. And then I'm going to stop the fan. Kind of like this particular power supply, there's a link in the initial video about this device, quiet virus filter. Although with this particular fan running at 2 watts, it's not all that quiet. To put a little bit of tape to hold this in place. Actually, it looks like I'm going to need a little bit more tape than I initially thought to get a good seal, because the putty isn't staying where I need it. Looks like that last bit is going to be a little bit more difficult to reach than the rest. Let's see what I can do. I've got a seal all the way around. And from previous experience, this is going to be a little bit tipsy. Now, one nice thing is I'm not worried about blocking the hole underneath as much because the fan is there. What I have to be careful about is just to make sure that I don't interfere with the moving part of the fan, which I'm not. That's reasonably enough protected in this design. It's slightly recessed. That means this filter is very much recessed. Recessed means it's not quite on the surface. It's a little bit below the surface. And for right now, I think I'll go with this. So now, this time the output is going to go where initially the motor was going. So I'm just going to put this, same thing that the motor was blowing into. The air coming from the filter will still go through it. The only difference is this time the fan's going to be at the opposite end. Let's see if this time maybe we can get a more stable connection with the putty. I think hot glue would actually be a little bit quicker than working with the putty, but that would melt this plastic most likely. The putty won't. It's also a little bit easier to remove than hot glue. It's actually about the same amount of time as working with caulk or epoxy. It's just don't have to wait Alright, I'm going to put a little bit of tape on this, because as you see, that is not stable with just the putty. Putty might be enough to keep it sealed, definitely not going to be enough to hold it in place. In fact, I think I probably could have just gone straight to the duct tape in both cases. Without even using the putty. The way you learn things is by trying them. It won't always work out. That should be a common refrain because it's true. Like tearing this tape, for instance. Sometimes just a little bit of persistence will work, and sometimes it's better to try something entirely different way. I don't know if that actually came through on the video, but when I was saying try something a different way, I use the scissors in a very unsafe fashion to cut the tape. After this, we'll get 3 more trials with this configuration, and we'll see whether or not there's a significant difference between blowing air into the filter or blowing air out. A more accurate way of saying it is blowing air in or encouraging the atmosphere to blow air in. Because the atmosphere is 15 pounds for every inch, which is quite a lot of pressure. Oh, this isn't coming apart. No, I think I still have a seal in there. Turn on the fan. Oops. And apply a little bit of some more tape to help with the flimsiness. I'm literally rocking my design project. Though figuratively not so much. Figuratively I'm more fumbling the project. So now we'll do the trial going in. Try to set up the meter so that you can see it. It's reading slightly less, which suggests this fan or slightly more wattage. This fan draws more watts, or draws less watts if there's more resistance. So a higher reading on this at the same voltage suggests that this design is actually more efficient. That could be for a variety of factors. In any case, maybe it's just how flimsy it is. Actually, a lot of it might just be how I'm holding the tube, because now it's down to 2 watts where it was on the other test. So this tube actually creates quite a bit of resistance. And that would be something to control for in another test, is to actually have the tube in a fixed position, because that could well be what's making a 3-second difference in the time. It might not just be me fumbling with the bag. Start stopwatch. Okay, so that was about 26 seconds. So it looks like it's the same amount of time either way. Getting a good healthy roughly 2 liters per second. Alright, go for the next trial and see if I can adjust the camera so you can see a little bit more of the, so that's the current setup. Very similar effectively to what we had before, except the motor is on the bottom. The bag is empty. Start stopwatch. And being more consistent this time. That might just be from practice. Do one more trial. Call it a wrap. Start stopwatch.